Hi everyone, with the group Newgen. Today we are going to introduce a system called Election Barometer, which we can predict who's going to be the next American president. For this presentation, we will talk about problems for the starter and the goal, that what we are thinking for the destination. Then we will discuss what the challenges and solutions to build them, and we will present what we have for detailed design. At last, we will tell you where we are and what we need to do for the final. Here's our problem in this presentation. There's going to be a presidential election next year, but how can you predict who's going to be a president between two Republican candidates, or between a current president or future elected Republican candidate? Still, only way we can predict is depending on the polls or surveys that would be done by CNN or other organizations. There's no such thing in current search engine. So what if we use Twitter? Because Twitter is the fastest media in the world today. If we can collect real-time Twitter messages that express supportive or not supportive opinions about candidates' political aspects in 50 states of America and visualize it effectively, this will be fabulous. To do that, there are two main challenges. First challenge is to choose the aspect we will show. We do not think it's a good idea to show all the aspects, because everyone is not interested in every aspect. We will represent only top 5 most popular aspects by gathering Twitter messages. Second, what standard do we take for classification? Basically, we use the meaning of the word. Based on the word people usually use for agree or disagree, we will classify the Twitter message by that. Now we are going to talk about detailed design. Here's a big picture for election barometer. From 1 to 2, we collect Twitter messages talking about a candidate and extract top 5 popular aspects by using aspect ranking generator. From 3 to 4, we will bring real-time Twitter messages with those 5 aspects, and 5 we will store in database to further doing aspect ranking. From 6 to 7, we'll use natural language parser and positive and negative classifier to classify the opinion is agreed, neutral, or disagreed. For more accurate result, refinery will be used. Finally, we will visualize it, and from now we are going to explain one by one. First, we will collect Twitter messages talking about a candidate in recent 7 days, and we will store those messages POS tagged by NER POS tagger. And we will implement political aspect ranker that will choose 5 most popular aspects based on counting number of mentions in database. And we will use these top 5 aspects to extract current tweets to show the result. We are going to use REST API, which returns JSON type tweets by users located within a given radius and given latitude and longitude. However, it is not easy to extract Twitter messages from each state, because there's no option for state in REST API. Of course, we can implement it, but it will bring performance problem. Instead, we get the geographical information of every state from wikipedia.com like this in advance, and we will use latitude and longitude from collected information and find the center of the state and draw a circle from the center that includes the most area of the state. Then we can actually get almost every tweet from that area. For analyzing messages, we are going to use Bayes formula. This formula has been used for spam detection for many years, so we thought we could take advantage of it to do sentiment classification. So probability of event P or N means probability of the tweet to be positive or negative. And for the example word cache, probability C given P is the probability that the message contains the word cache among positive messages, and followings are same pattern. At the end of the branch, we can find the intersection, like probability of P intersect C, that becomes probability of event P multiplies by probability of C given P, and also probability P intersect not C, that becomes probability of event P multiplies by probability of not C given P, and the other two become just like above. So by this theorem, probability of the tweet that contains the word cache to be positive is like this, probability of P given C, and vice versa becomes like this in the right side. Based on the theorem above, the classifier that would use the hypothesis that both positive and negative cases to be equal probability of 50%, and they are said to be not biased, then we can simplify the general formula like this. And if we say one tweet is a combination of a word 1 to word n, the overall probability of a tweet becomes positive with containing the word from 1 to word n. We will prepare same size positive words and negative words set from several websites, but we still need to have a standard to judge which messages agreed, neutral, or disagreed to candidate's idea about a certain aspect based on the probabilities from formal calculation. So what we are going to do as a standardization, if probability for positive of a message is more than 50%, then we will say it's agreed, and probability for negative of a message is more than 50%, and then we will say it's disagreed, event anywhere else are neutral. And we need refinery to compensate the weaknesses of Bayes' formula. So we have two compensators. First one is for the situation that one sentence with two candidates with comparison. If a message contains comparison words such as compare to or than, which could be differentiated by POS tagger. If the sentence before the comparison word is positive, then the tweet is positive for A. If the sentence is negative, then the tweet is negative for A. And the second is for the negation. If there's negation word like not, never, the probability of a message to be positive is 1 minus probability of event P. At last, here will be our result for the project. For each candidate, we are going to show the percentage of agreement in each state, and we'll have top 5 aspects that are different as time changes. Before we finish our presentation, we'd like to talk about where we are and what we need to do for the final. We almost finished to implement the extractor module, and we have the spike for natural language parser and classifier using Bayes' formula. Until the final presentation, we'll have elsewhere we mentioned. For the refinery part, we're going to focus like what we can have more and better solutions. Thank you for listening.